In this lecture, we're going to learn about constructors. And constructors are special class methods or functions that are called by the compiler to construct your class objects. And they are special because they have no return type. A constructor can never have a return type, as you see here. They have the same name as the class. So for example, for our class in the last lecture that was called Cylinder, the constructors are also going to have the same name as the class. They are going to be called also Cylinder. Constructors can have parameters, but if it makes sense for whatever it is you are trying to do, you can also leave the parameters out. And constructors are usually used to initialize the member variables and put them in a state where you want them in your C++ application. Let's look at how you can declare constructors for your classes. Here is our Cylinder class. You see we have our member variables they are private now, and we have a public section which is going to have our functions or behaviors as you see here. The member variables are what we have seen from the last lecture, but if you look here, we have a few new things here. We have two things that look like functions, but they don't have return values. That's something you should notice. They have a parameter list, as you see here, and we have a pair of curly braces because these are really functions. And these are special functions that are going to be called by the compiler to initialize your class objects. If you look here in this example, we are using the constructor with no parameters to initialize our member variables to 2. And we have another constructor, as you see down here, which is going to take parameters directly. And it's going to take the radius parameter and the height parameter. The parameters are of double type because that's what we expect in our class. And we are passing them by value here because they are fundamental types and we don't really mind copying them. But please keep in mind that they are going to be passed by value, and what you have inside your constructor body are going to be copies of the original arguments that were passed to your constructor. And this is really how you declare constructors for your C++ classes. Constructors can either have parameters like we have again on this example here, or they can have no parameters. And this is going to be a default constructor. We're going to see that this is going to be called when you try to create variables of this cylinder type without passing the parentheses like we do when we call this second constructor here. We're going to see this in a minute. Okay, this is all I think I have to share in the slides about how you declare constructors. Let's head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is constructors. We're going to put in our template files. Pretty quick, let's do that. And we are going to open this in Visual Studio Code by dragging and dropping on top here. This is going to open our folder. Let's open our main CPP file. And we're going to take out what we don't need in the main function and on top here. And I am going to reuse code from the last lecture because we don't want to type that again. So let's put in our class definition. We have our variable pi, which is going to be used to compute the volume in the class here. And we have member variables. Okay, now that we are here, let's change the member variables to be private, because making them public is really going to be bad design. It's going to expose them in the main function and people can mess with them and really change the logic of how our class works without our consent. It is advised to make your member variables private unless you really have a compelling reasons to make them public. Okay, now that we have our class here, let's set up constructors for it. So we're going to go down here in the public scope and say constructors. And we're going to set up the first constructor, which is not going to take any parameter. So we're going to say the name of the class. Remember, a constructor doesn't have a return type and it has to have the same name as the class. So we need to comply with that. And we're going to put our pair of curly braces, and inside we're going to initialize our member variables however we want. So what we're going to do here, we're going to set the base radius to something. Let's make it a 2, like we saw in the slides. No problem with that. And we're going to set the height to something else. And we are going to set the height to 2 as well. We can do that. You can use what you want. And now we have our constructor, and it is initializing our things. Okay, now that we have the constructor in place, how is it really called by the compiler? And notice that our constructor is in the public scope of the class. If it isn't public, you won't be able to access it from the outside, and the compiler will fail to build your objects. And we're going to see this in a minute. But before we do that, let's try and create a cylinder object now. So we're going to say cylinder and say cylinder1, like we did in the last lecture. And when we do this, notice what we see if we print the volume of our cylinder object here. This is an object because we're creating this from our blueprint, which is the class definition here. You really need to know this. This is a class object. Let's say that. And we're going to print its volume. We're going to say cylinder1, and we're going to call our volume method, we should say. And if we build, you're going to see that this is going to work, but the volume is not going to be coming from the initial values we have here. We will have changed these guys to 2 from our constructor here, because the compiler is going to look at this line here and see that we are trying to build a cylinder object. It's going to look at the class definition, and it is going to say, do I have any constructor that I can use to build an object from the syntax I see here? And it's going to see that it has a constructor that doesn't take any parameter, and it's going to use it to build our object. And it's going to be using this information to build our cylinder object. So the base radius is going to be 2, the height is going to be 2, and it's going to use that to compute the volume that we print here. You really need to understand this. Let's build and see if GCC accepts this. You see the build is good. Now we can bring up a terminal and clear and run Rooster. You're going to see that we have 25 something, which is a result of using this information we have here. If we take pi, multiply by this base radius, multiply by this base radius again, and multiply by height, we're going to get this here. You can try this out. It is going to be what you see here. And this hopefully proves that the compiler is using our constructor here. But we can also use a debugger. Let's set up a breakpoint here, and we're going to run this through our debugger. We can come back to the run tab here as we have done before, and we're going to try and use the debugging tools that come with the GCC compiler. That's what we can use. If you are on Windows, you can also use the debugging tools that come with the compiler from Microsoft. But we're not going to use that now. GCC is going to be fine. We're going to start debugging, and we should hit our breakpoint when the build is done. Let's wait a minute. Okay, we have hit our breakpoint. We can minimize this a little bit and show the terminal to the right here. I think we can do that. Let's do that. Let's put that a little bit to the right here and minimize a little bit. Okay, we have our thing in place. We have hit our breakpoint. You see, these are the local variables we have here. We have a cylinder object, which is not initialized yet because you see what we have inside is really junk data. We haven't put in anything yet, but now that we are at this breakpoint here, we can hit step into the code that constructs our cylinder object. Because at this point, line 25 here hasn't run yet. So we're going to step into, and you're going to see that we hit the constructor for our cylinder object. And this again proves that our constructor is being used to build our cylinder objects. Now we can move to the next line. We're going to set up the base radius. And if we hit next here, this is going to set our base radius to 2. And you see that height is 1 because we haven't set it up yet. But if we execute this line, you're going to see that height is also going to change to 2. And now if we hit next, we're going to get out of our constructor and our cylinder object will be already constructed. If we look again here, we're going to see that radius is 2, height is 2, and we can print the volume. And if we hit step over, we're going to see our volume printed out here. Hopefully, again, this proves that our constructor here is being used to build objects. And it is doing that because it is the syntax here. We don't pass any parameter to our cylinder object as we create it. So this must be calling the default constructor, which doesn't take any parameter. This is the message here. Let's close our debugging session and maximize our Visual Studio Code instance, because we're going to set up another constructor which is going to take parameters now. And you have seen the syntax to do that in the slides. It is nothing complicated. We're going to say the name of the constructor, which is going to be the name of the class, and we're going to say double and say rad param for radius, and we're going to say height param for our height, and we're going to make this double. And after that, we're going to head in the body of our constructor, and we're going to initialize our guys to the parameters that will pass to the function here. And this is really powerful. After we have this constructor n, we will be able to pass parameters that will be used to construct our cylinder object. So we can say base radius and pass in rad param, and we can say height and say height param here. And these are going to be used to construct our object. Now we can head over in the main function and change how we construct our cylinder object. If we want to use 10 as the radius and 5 or 4 as the height, we can do that by passing arguments to our constructor here. Let's run this through the debugger again and see that our information here is being used. Now, this constructor here is going to be chosen by the compiler because it is more fitting for the call that we are doing here. Let's run our debugging session. The program is going to be built, and we are going to try and maximize this a little bit and bring up our terminal output. Okay, we have hit the breakpoint here. We can step into our constructor and notice the constructor that the compiler chooses. Our constructor that takes parameters is chosen here, and we can do things inside. Let's hit next. We're going to initialize the base radius to 10, and we're going to initialize the height to 4. Okay, we can see that to the left here. If we hit next, the height is going to be changed to 4, and our constructor is going to be done. We're going to head over in the main function again, and if we step over, now we're going to print a new volume, which is based on the information we use to construct our object here. This is really what constructors do. They are used by the compiler to build your objects, and we saw the syntax we can use to set up constructors for our own classes. Okay, now you must be saying, if we need constructors to build our objects, why was the code in the last lecture working? In the last lecture, we did something like this. We said cylinder 1, and this was building and compiling fine. And let's try and take out our constructors. We can do that. Let's comment them out. And if you look, you're going to see that the code is going to compile fine, even if we don't have any constructors in here. Let's build with GCC to show you that the code is going to compile. Build is good. So how is this working? How is this constructing our objects, even if we don't have any constructors in here? Well, the reason is the compiler is going to set up its own constructor, and what it is going to set up is a constructor which is really empty and doesn't have anything inside. It's basically going to be as if we put in an empty constructor. Let's copy this and actually show you this. We can do that, and we're going to make this constructor empty and not do anything in the body. This is the constructor that your compiler is going to generate. And if we build now and try to set up a breakpoint here, you're going to see that our empty constructor is going to be chosen. Let's debug and show you that. Okay, you see that we're going to hit the breakpoint here. And if we step into, the compiler is going to choose this guy, and it's not going to do anything. So it's basically going to take our member variables as they are, and it's going to use the information to print the volume here. We can hit next again and get out of our constructor. And if we step over, we should print our volume, which is going to be 3.14 because the compiler just used the initial values we have in our member variables here. So again, the message is, if you don't have any constructor in your class, the compiler is going to generate an empty constructor for you. And the empty constructor is going to take no parameters, and it's not going to have anything in the body. It's going to be an empty constructor, and it is called a default constructor generated by the compiler. This is really all I had to share in this lecture. I hope you found it interesting. Now you should have enough knowledge to build your own constructors for your classes. We are going to stop here in this lecture. In the next one, we're going to learn about default constructors. Go ahead and finish up here and meet me there.